Alright, so let's go over the adding polynomials notes. So I want you guys to go ahead and get out your note packet and take notes and fill out the information. If you need to pause this video, obviously you should do that. You should pause so that you can finish taking the notes. Okay, so we're going to transition here. We did classifying polynomials last lesson. And now we're going to do a little more with polynomials. And before we do that, we're going to review some old stuff that we know, which is called like terms. So we learned about like terms back when we solved equations, back in chapter 3 of linear algebra. And what like terms are where the variables are the same and exponents are also the same. And so an example of this would be these two examples. Notice how there are coefficients in front, the number 4, the number -3. We're not necessarily looking at those right now. We're only focused on the variables to determine if they are like terms or not. So if these are like terms, they will have the same variables, same exponents. So you would notice that you see an x squared y and then another x squared y. We would say this term here is a like term with this term here. And a non-example would be this one. You can see how the x in this first term would have a power of 1, but in the other term it has a power of 2. And so automatically that would not be like terms because the x's are different, but it also happens to turn out that the y's are also different. But just one slight discrepancy between one variable's exponent, then that would be not like terms. So everything has to match perfectly. And one thing to keep in mind is that you could see the order change. And so you see in this term on the left, we still have an x to the power of 2 and a y. And in this term on the right, we still have an x to the 2 and a power of y. It's just these switched order. And that's okay because everything in this term itself is multiplication. Everything is crunched together, and so it's multiplication. And so the commutative property tells you can switch those. It means the same thing. So in this case, what I wrote here, they would also be considered like terms. All right, moving forward. Let's go to the next slide. Can we go to the next slide, Mr. Herb? Can we move on? No, we can't. So let's just back out. Where'd the rest of the slides go? Here we go. Alright, so we're going to decide whether these are like terms or not. First one, we have an x, y, z, but in the second one we have this power of 3, so they are not the same. So that is a no. Part B, we have a power of 3 and a power of 2. Those are different, so that is a no. In part C, we have an x squared and an x squared, so this is a yes. And in part D, we have an x power of 1, y power of 1. We have an x power of 1, y power of 1. So although this order changed, we still have the same variables and the same exponents. So in this case, C and D are like terms. A and B are not like terms. Moving forward, I wish this would hide so I could next my screen, but I'm just going to exit out every single time. Oh, it's adding a new page every time. That's great. Okay, so when we add polynomials together, like this example, we're going to be combining our like terms together. So first thing to do is to identify the like terms. So we're going to go ahead and I'm just going to highlight and color code what's like. So we have an x to the power of 4. Right here we have an x to the power of 4, and that's it for x to the power of 4, so I'm going to go ahead and change my color. I'm going to identify x to the power of 2's. Notice how I also highlight the sign in front. That is important. Let's see, let's do blue. We have a regular power of x, and right here we have a regular power of x. And then what's remaining are also different like terms. So I'm not going to go ahead and highlight those because they don't have any like terms. So let's go through here. Let's start with our power of 4's. We have, basically we're just going to count them. So we're going to write x power of 4, and we are going to say how many of those do we have. Well, we have 3 here, we have 2 here. We're going to add the 3 plus the 2, but that means we have 5 of them. And usually a good rule of thumb is to go ahead and write these from highest to lowest. And so I just did power of 4, so kind of these are done. Do we have powers of 3? Yes, right here's a power of 3. We do not have any like terms for the power of 3, so we will not do anything with it. We'll just move it down to our answer. Then our power of 2's, we have a -2 of those. Okay, and then moving down another power of 1, we have a +1 of those and a -1 of those. If you add a positive and a negative, you get 0. So those actually cancel out. And so our 4 drops down into our final answer. And this, although it looks like a lot of stuff, that is your simplified final answer. Okay, so we're just combining all our like terms together. Clear annotations, and then let's exit out. Let's go to next slide. Okay, so here we'll do this again. We'll identify our like terms. Here we have an x to the power of 2 and an x to the power of 2. Then we have a negative 4x and we have a 7x. Those are like terms. And then lastly, we have our constants, so our numbers that do not have variables. And then we'll go ahead and we will combine these together. So here's these two. We're going to count how many there are. So we're going to identify they are x squareds, that's what they are, and we're going to add how many we have. We have 2 plus 1, so that would be 3. Moving on to the x's. How many x's do we have? We have negative 4 plus 7, so that's going to be 3, a positive 3. And then the last one in maroon, our constants, we have a 3 and a negative 9. Add those together, you get a negative 6. And so there is your final answer. Notice how your exponents, your powers, your exponents are not changing. So I know we just got done doing our exponent rules where we change the exponents, we add them or multiply them together. But when we're just adding polynomials, we don't have to change the powers because we're really just counting how many we have. We're combining them as a group, but we're not multiplying them together. And so that's a very big difference. And honestly, it's much easier to add them than it is to multiply them. So next one, we have some y's here. Here's 2y, here's 12y. We can go ahead and let's go ahead and put those together. So 2 plus 12 is 14. And then that's not going to show up good. Green, we have, here's an xy, negative 5 of them. Here's a positive 3 xy's. We'll put those together and call them negative 2 because we'll just add their coefficients. And then lastly, we have this positive x, we have this negative x. Those added together make 0, so they cancel out, and so we are finished. That is our final answer. Let's see, do we have the right microphone on here? Hopefully. It would be a shame if this wasn't recording. And we'll make this the last example, so let's see how this goes. Do not restart. Okay, last one. Let's go ahead and let's highlight. Actually, this time we'll try to highlight. So we have a y squared x, so we're going to look for another y squared. And right here we have a y squared x, so this is a like term. That's it. We'll change our colors over here. Let's go to green. We have an x to the power of 2y. So we'll look for an x to the power of 2 and a y together. Right here it is. And that's it. Let's go on to the next thing. We have a 5x. So we're going to look for just a regular x. That's over here. And then, what's remaining looks like they're like terms as well. So let's pick brown. There we go. So we've identified all of our like terms, and now we're going to go ahead and combine all of our like terms. So here we'll take these two. These are y squared x's. That's what they are. How many of them are there? 5, and negative 9 makes a negative 4. I don't want that. There we go. Okay. Next one, green ones. These are x squared y's. How many are there? A 3 plus a negative 2 is a 1. So honestly, I don't need to put that 1 there. I can just put plus. On to the pink. 5 and 7. So that makes 12. There are 12 x's. And then lastly, we have our xy's. How many of those do I have? I have negative 5 plus 3 is negative 2. And that will be your final answer right there. You cannot put any of these together because they don't have like terms. So this is my final answer. Thanks for watching. And that should do it for the video. Let's exit out.